Hello, everyone. Thank you for having me here. So I'm going to talk to you today about how AI is more than chat, and give you some practical examples, or a practical example actually, of how AI is being used. Because I think there's not many very practical, non-technical examples out there sometimes. So I'm going to try and do that today, hopefully without too much techie stuff. So my name is Chris Ballard. I've worked as a data scientist for about 15 years, in the tech sector for 25 years. I run my own AI consultancy business, which you can check out there at that web address. And I'm going to pull you in with a picture of my dog to start off with. So I've a couple of things about me. I've got a rescue lab called Maddie, and I do home brewing as well. But I haven't yet found an opportunity to integrate Gen AI with home brewing, but maybe there is a way of doing that. So now that I've pulled you in with a cute dog picture. So, chat is what we're familiar with when we think about AI. We've seen lots of examples of that just now with the previous speaker. And we're used to interacting with text, asking it questions. But AI is more than that. We can do very specific things with AI, and I want to give you a flavour of the kinds of tasks that we can get AI to do, and also ask the question of whether we need to use Gen AI to do that. And we touched on it earlier on. Actually, that was a nice introduction, actually, in my talk. Earlier on in the last talk, we talked about how generative AI uses so-called large language models under the hood. And those large language models are trained against extremely large data sets and essentially have learned to predict a sequence of text, what should come next after it sees the text that comes before it. Those models are extremely large. You can actually go to that web address on the bottom right-hand side, and you can visualize a large language model. And actually, it can tell you about it and how it works. It gets a bit technical. And this is a very small language model. Don't worry, I'm not going to go into the details of what any of those things are, but these are the underpinnings of things like ChatGPT. And that's a much larger version of the language models. They're extremely, extremely large. But AI is more than that. AI encompasses a whole raft of different techniques and tools, and can be applied in different ways. And what we've been talking about with Gen AI is really what I would term machine learning, teaching machines, teaching algorithms to make decisions from data. And they're also, what we've seen are examples of natural language processing. So enabling machines to understand text and make decisions from text as well. But also AI encompasses other areas as well, like computer vision. And what we're seeing with those multimodal models that we were talking about a moment ago is the real bringing together of the natural language side of things and the computer vision side of things into multimodal models as well. So I've wanted an excuse to use I forget the name of this film now. What's the name of this film? Yeah, it's Jerry Maguire. Yeah, I wanted an excuse to use this meme in a talk I was going to do. So I want to really show you the money here and talk about a practical example, though, because how are those different techniques actually being used? And so I'm going to segue into phishing. Not this kind of phishing, but phishing emails. You'll all be potentially familiar with phishing emails, the types of emails that bad actors send to businesses all the time, which look very legitimate and try to extort or get you to release sensitive information like financial information, for example. And over the last couple of years, I've worked on detection of those kind of emails, particularly the advanced kind of phishing emails, those that somebody does a lot of research into the person that they're sending it to, and may use techniques like impersonating somebody they know to make it incredibly difficult to detect. And we're using AI to detect those emails today. I want to give you some practical examples of the kind of types of emails that we're looking at. I thought I'd give myself a career boost and become a chief exec, but CEO impersonation is a very real impersonation tactic with phishing. The kind of things you might see are somebody impersonating the CEO of your company, dropping you a line and saying, "I've got this really urgent task for you to do. Drop everything, but I can't take a call right now because I can't be disturbed." Encouraging them to do it via email. They can be, when you know what you're looking for, quite easy to spot. But once you mix that into a busy day and lots of email and things like that, it's easy to slip up. So that's one example. Another example, which can overlap, is what we term a conversation starter. So it's somebody emailing you, often impersonating somebody like a CEO, and trying to engage in a conversation with you. That initial email might not ask you for information up front, but they want to engage in a conversation, and during the course of that conversation, they may try and extort information out of you, or get you to send a sensitive document or something like that. Conversation starter. A business proposal. I think this one's actually really obvious, but they can be less obvious than this one. So some amazing business proposition. You've got the opportunity to invest in a new business or something like that, Microsoft impersonations, Google impersonations of big kind of corporate entities who might send out either automatically emails asking you to change change your password, for example. That's extremely common as well. So the question is, how do we detect those emails? In the environment we've been working, we were missing quite a lot of those very textual, very real-looking emails. And so part of our job was to look at, how can we detect those kind of emails in a much better way? Because actually, going back to that big fish, we were detecting the big fish, but under the surface, there's this whole sea of phishing emails. It's a big risk to companies. So one of the things we could do is, using AI, is that we could train a model by showing it lots of examples of emails, those different types: conversation starters, business proposals, personal opportunities, maybe legitimate emails like out-of-office replies. We could show it lots of examples of emails like that. We can give it that model the text and ask it to make a decision. But there's also lots of other information in an email as well. You don't tend to see it in Gmail or in your email client, in Outlook or whatever. There's lots of headers that show you where the email came from, how was it routed through servers, things like that. We could also potentially use that information as well. But then also we could use interactions. Email is not static. It's not just one email. It's information about, has this recipient been in communication with the sender before? Or does the sender look like somebody like the CEO who actually the recipient has already some established relationship with? So interactions can be useful as well. And this kind of mechanism to train a model is what we call in data science supervised learning. We're supervising a model by showing it examples that we already know and classifying a result, so categorizing those emails. Now, the problem with that is traditionally we need lots and lots and lots of examples of those kind of emails to be able to train a model to do that. And actually in this particular project, we had tens of examples of each email, maybe 20 examples of conversation starters, not very many. And go back 5, 6, 7 years ago, that would have been an extremely difficult problem to solve without lots of people manually labeling emails, lots of time, lots of cost. So we could use a large language model like ChatGPT maybe to do that. The specifics about what I prompted ChatGPT here to do are not that important, but what I asked it to do was, can I classify this email and explain whilst it chose the category? And it gives me an explanation. It says, in this case, it's a CEO impersonation. We could do that, but there might be lots of reasons why that isn't a good idea. So one of those could be, and is the case for our project, actually we process in the last 30 days, we processed 1.25 billion emails. And so cost and how quickly that model runs is extremely important. And one of the issues that we'll have is if we used a large language model in production would be time and cost, really. But also context as well, and providing that additional information is difficult. So that's a challenge. So what if we could ask a model to learn from the limited data that we've got in a way that doesn't require lots of manual work? One of the amazing things that's happened over the last 5 years, in addition to the models like ChatGPT that you'll know about, is there's a massive open source community of these transformer models that were referred to earlier on. And I can go on a platform called Hugging Face and I can look at 500,000 plus models that have already been trained on large data sets, much larger than our 1 billion emails that we process every day. And we can take those models, we call them pre-trained models or foundation models, and those models know general knowledge of language, and we can fine-tune them for a particular task. And what that means is we can train a model now using significantly less examples than we did before. Hundreds, and that's exactly what we did for this project. So still some labeling, but significantly less. And what are the benefits of that? So that reduces the manual labeling cost, significantly. We've reduced the time from research to production to weeks, 8 weeks, from no model to having a model and solving that problem for the clients. That deploy model can handle 50,000 requests a minute. That's not going to happen if we were using a large language model. That was really important. And I did a quick comparison of the cost. This is very rough and ready. Had we used OpenAI's API to solve that problem with their cheapest model, with the volume of that data, it would be roughly costing $200,000 to $250,000 a month, whereas the actual cost of that model, which performs just as well, is about $15,000 a month, so significantly less. So kind of the takeaways I want to kind of leave you with today is that generative AI and clearly chat interfaces are a high profile and very useful application of AI, but where you've got a particular use case, you really need to consider carefully that use case and limitations for things like how quickly does that system need to respond to requests? How many requests are we going to get? Weigh up accuracy that you need from the system versus what the cost would be. Sometimes we can compare two models, one which is very much larger than another one, but the large model can cost significantly more and maybe only gives you 1 or 2% more accuracy. It might not be worth using a large model in that situation. So not all problems are necessarily best solved with an LLM, but one thing I think that we do that they excel at is really quickly proving out a use case, generating data that we can then use to train much more tuned models for particular tasks, like this example I've just been talking through. So thank you. Hopefully you found that useful, and 1 or 2 questions I've got time for apparently. Tumbleweed moment. Oh no.
With using models found on published behaviour, is there not a risk that those themselves may be vectors for phishing, and that the bad actors could be engineering potential backdoors in precisely to allow raw models and powerful models to issue false negatives to their specific
That's a really, really good question. So one opportunity, I think, for downloading malicious code is to download malicious code. Obviously, when you're taking a model from Hugging Face, there's code there. That's kind of addressed with the way they handle that, because what they do is you can just download what would be called the weights. So you don't actually download for the code for the model. It's the weights that the model uses.
The model itself. If someone publishes a model specifically around, let's say someone made a model for others to use to detect phishing, that model could itself be deliberately trained to allow a very specific type of phishing through, so that they can exploit that phishing detect.
I think that's a very real point, yeah, which goes back to really having very good established testing protocols for how the system that you build on top of that is used, and also being very aware of having somebody who's very aware of what pre-trained models you're using. So I generally, for these kind of situations, wouldn't use a model that's been trained by somebody who I don't trust. I would probably take one from an organisation, who is known for producing open source models like that, and has those kind of guardrails in place to prevent that. Thank you.